From high-tech to business tech to everyday tech, there isn't anything you can't find, only things you can't imagine. And Chinese solar technology light up homes for African kids who used to study by candlelight just like me when I was growing up.
What if entire cities could commute at airplane speed, and your EV battery could bend and flex without catching fire when things go sideways? China is quietly pulling off what sounds like a sci-fi fever dream, with quantum computers that outpace the fastest machines, air taxis that fly themselves across skyscraper canyons, and maglev trains that can make a trip between Beijing and Shanghai feel like a coffee run. This isn't just about flashy tech, it's a relentless mission to remove every friction that slows the world down. But beneath the headlines, what's the secret force propelling this new wave of world-changing breakthroughs? But first, could the world's biggest innovations actually be parts of one master plan? The secret engine, China's war on friction. All right, hear me out. We've seen quantum computers in China cracking problems in a few hundred seconds, which would take even the world's fastest supercomputers longer than the entire human civilization to finish. We've seen air taxis lifting off rooftops in cities where traffic jams used to hold people hostage for hours. Maglev trains are gliding at 600 kilometers per hour, while EV batteries are being built to flex and absorb crashes instead of turning into fireballs. These aren't just cool gadgets sprinkled around to boost national pride. What if they are pieces of a bigger strategy, a mission China is running to eliminate friction wherever it hides? Inside computers, inside cities, inside daily life itself. In a TED Talk, economist Ku Jin explained how China's breakneck speed isn't random.
From high-tech to business tech to everyday tech, there isn't anything you can't find, only things you can't imagine.
It's baked into a playbook where local governments compete to clear red tape while funneling resources directly into companies. The Carnegie Endowment backed this up, showing how China turns policy into actual hardware faster than almost anyone else, because it's not just about ideas, it's about rolling them out at a scale that would make even the most ambitious Silicon Valley founders sweat. Think about it like this. Friction slows you down. Whether it's a bottleneck in a supply chain, a jammed street, or the sheer computing time it takes to simulate molecules for a new drug. China's new generation of innovations, from quantum computing with Zhujiang and Zhuangzi, to maglev travel, to automated air taxis, to the Blade battery's crash-absorbing architecture, all attack that friction head-on, compressing what used to take days, hours, or years into moments. Is this a coincidence? Or is it an orchestrated speed stack, a national strategy to remove every drag on progress so that China can leap ahead while the rest of the world is stuck waiting for a loading bar to finish? The truth might be uncomfortable if you live in a country still struggling to get a single high-speed train line approved within a decade. And that's the real question. But if there's a master plan, what's at the sharpest tip of this technological spear? What happens when computers begin solving the unsolvable millions of times faster than anything else on Earth? China's leap to the future. Now, this is not some vaporware sales pitch or a random headline to scroll past. It's what's already happening inside labs in China, where photons and qubits are pulling off calculations that would take the world's beefiest supercomputers longer than human history to finish.
Quantum computers would then simulate molecules, for example, leading to the development of new drugs.
We're talking about quantum advantage, and it's one of the wildest parts of the Chinese innovations that will redefine the world forever. Because if you've ever complained about your laptop freezing on a spreadsheet, imagine having a machine that rips through the hardest problems in moments, leaving old systems in the dust. Let's break it down. Zhujiang, China's photonic quantum computer, did something in 200 seconds that would have taken even the Sunway Taihu Light, one of the world's most powerful classical supercomputers, an estimated 2.5 billion years to complete. And that was back when it was only working with 76 photons. By 2023, Zhujiang 3 was clocking in with 255 photons, pushing its calculation speeds 10 quadrillion times faster than Frontier, the leading classical supercomputer in the world. Yes, 10 quadrillion. Now, on the superconducting side, China's Zhuangzi series has been moving just as aggressively. In 2022, the Zhuangzi 2.1 used 56 qubits to finish a sampling task in about an hour that would have taken 8 years on a classical computer. By 2025, Zhuangxi 3, now with 105 qubits, ran random circuit sampling a million times faster than Google's best public results. It's not just about posting speed records on a lab door, either. It's about the possibility that quantum AI, advanced materials simulations, or even drug discovery pipelines could move from theory to practical use. And it's not just government labs doing this. Origin Quantum, a Chinese startup, rolled out the Wukong 72-qubit system as a deliverable superconducting quantum computer, signaling that commercial players are stepping up. They even built a full-stack quantum operating system called Origin Pilot, handling multi-processor scheduling and auto-calibration, something many Western stacks still treat as a future feature. Now I know what you might be thinking. Why does any of this matter if we can't buy a quantum laptop tomorrow? Think of it like this. Quantum computers excel at handling problems involving absurdly complex variables, from simulating molecules for next-generation batteries, cracking codes, and training AI models beyond what's possible with classical chips. These machines can handle friction in the world of computation, removing bottlenecks that limit the pace of discovery. It fits perfectly with China's bigger mission to remove friction wherever it hides, pushing human potential past the speed limits we've grown used to since the 1980s. There are online videos with thumbnails saying, "China destroys Google," splashed across the screen. But beneath the hype, the receipts are there, backed by peer-reviewed data, lab demonstrations, and credible conference results. This isn't a story about a single machine. It's about how China is systematically building quantum momentum while others argue about budgets or whether the tech is ready. And if China is winning the quantum race, how long before that advantage transforms AI security, encryption, global logistics, or even gaming? Imagine games that can generate entire worlds in real time, or cybersecurity frameworks that shift so fast that hackers don't even get a chance to knock. Could China's next quantum leap make all of that happen? And what if that same friction-fighting spirit could take to the sky and make flying taxis real? And if it is possible, who will be the first to hail a flying taxi? New Yorkers or Beijingers? The birth of autonomous air mobility. If you think flying cars are some 80s sci-fi promise that never happened, look at what's quietly unfolding over the rooftops of China. This is the Chinese innovations that will redefine the world forever. And the next piece of that puzzle is the EH216S. This fully autonomous, passenger-carrying air taxi isn't just a prototype buzzing at a trade show. It's certified, delivered, and cleared to fly real passengers. We're talking about the first air taxi in the world to get a type certificate from a national aviation regulator, something EHang pulled off in October 2023 after a 31-month regulatory process that put safety and reliability under the microscope. And it didn't stop there. Just a few months later, the EH216S received its standard airworthiness certificate, meaning it's not just safe, it's production-ready. EHang delivered its first customer aircraft in December, confirming this isn't a one-off stunt, but a product ready for scaling in Chinese cities. Imagine hailing a fully autonomous air taxi from your phone, watching it land on a rooftop pad, then stepping in as the rotors spin up and the system locks your destination without a pilot on board. You get a front row seat to the cockpit view, with the city stretching out below you, traffic lights flickering far beneath as you rise above the gridlock. It's not fantasy pricing either. A CNBC field test in April 2024 revealed the unit price at around $330,000. That's cheaper than many high-end sports cars, with EHang's cloud-based route management allowing these air taxis to operate like a fleet of autonomous drones, but scaled up for human passengers. The ride? Smooth, fully automated, with the navigation system handling everything from altitude adjustments to wind compensation without a human hand on the stick. The real game changer here isn't just that these aircraft can fly, it's that they can scale. EHang developed cluster management cloud software to handle multiple air taxis simultaneously, allowing for an entire network of urban air highways above congested cities, managed digitally to keep flights efficient and safe. Instead of gridlocked highways, imagine layered air corridors above cities like Guangzhou or Shanghai, each drone-like vehicle gliding to its landing pad with zero emissions and minimal noise compared to helicopters. This is what happens when China's war on friction meets the skies, slicing through urban congestion with a system that was engineered from day one to remove pilots, waiting times, and the barriers that keep people stuck in traffic. It fits perfectly into the bigger story of China's relentless drive to make impossible things practical and practical things scalable, with speed. Now, will these air taxis become as common as Ubers? Maybe not tomorrow, but the groundwork is here. Certification hurdles have been cleared. Pricing is at a point where businesses and governments can deploy pilot programs, and the public is already seeing these in action, not as hype videos, but as working transport. This kind of real-world proof signals that a tech is about to go from cool clip you see online to normal part of the commute. But what if your daily commute could outpace an airplane on the ground? I mean, why ride the skies when a train can race faster than most jets? Breaking the speed barrier. It sounds like the kind of promise we were all sold back in the 1980s when sci-fi movies pictured sleek pods zipping across continents while we were still stuck in traffic. But China is making that promise real with its 600 km/h Maglev, the fastest ground vehicle in the world, filling the gap between high-speed rail and aeroplanes in a way that could change how cities, jobs, and even weekend trips fit into our lives. And this is exactly the kind of momentum that fits into the Chinese innovations that will redefine the world forever. Here's the thing. High-speed rail in China already runs at about 350 km/h, which is fast enough to shrink massive countries into regions you can cross in a few hours. But between rail and flight, there's always been that awkward middle zone where flights are too short to justify the wait at airports, but too long to drive comfortably. The 600 km/h Maglev closes that gap, making it possible to travel from Beijing to Shanghai in about 2.5 hours, gliding quietly above the track with zero friction from wheels or rails. This isn't a one-off science fair demo either. The prototype Maglev rolled out in 2021, developed by CRRC.
China's new 373 mph bullet train is now the world's fastest land vehicle.
China's major rail manufacturer, building on Trans-Rapid technology while adding their own innovations for scaling, control, and passenger experience. And the inside isn't a basic train cabin either. The production prototypes are fitted with transparent smart cabin tech, like Luminex transparent display windows, turning the ride into an immersive moving window that can display route info or flight-like entertainment without blocking the view of the landscape rushing by at speeds that match a cruising plane. But here's what makes this fascinating. The Maglev is not just about speed, but a lifestyle shift. A train running at 600 km/h changes how people think about jobs in different cities, family visits, and even how businesses can operate across massive distances without the costs and emissions of short-haul flights. It could transform the social fabric of countries that adopt it, giving people airplane speed with subway simplicity. Now, will this technology extend worldwide, or will politics, patents, and different urban layouts slow it down? That's the question. China has shown that it can clear the bureaucracy to roll out this technology, while many other countries are still debating how to get traditional high-speed rail up and running. The possibility of a network of these Maglev lines across Asia, Europe, or even parts of North America is a conversation that's already happening in infrastructure circles, but whether it can move past conversation depends on who's willing to take the friction out of transport policy and replace it with engineering momentum. And while speed thrills, what's keeping EVs fireproof and future-ready? The BYD Blade battery revolution. It sounds like one of those late-night shower thoughts, but for BYD, it became a blueprint for recharging the world with a battery that could redefine what we expect from electric cars forever. We've all seen those viral EV fire videos. with flames tearing through fancy logos while someone yells in the background. The BYD Blade battery was designed to kill that fear, replacing it with a cobalt-free, cost-friendly, fire-resistant pack that doesn't just power the car, it becomes part of the car's skeleton. And yes, this is part of the Chinese innovations that will redefine the world forever, because it's a piece of China's friction-fighting puzzle, quietly fixing one of the biggest headaches in the EV world without shouting about it on a Vegas stage. Here's how wild this is. During nail penetration tests, which simulate the worst-case battery puncture, rival chemistries would spike to around 500 degrees Celsius, often catching fire or exploding. The Blade battery? It hit only 30 to 60 degrees, staying cool enough to touch. This means that even in the worst crash scenario, your EV is way less likely to become a viral fireball. But BYD didn't stop there. The Blade structure isn't just a box of cells sitting in the floor pan. It actually acts as a load-bearing beam in the car's chassis, allowing the battery to double as a crash, absorbing backbone while still holding energy. It's as if your phone's battery were also the frame, keeping the structure solid while powering everything inside. This structural innovation improves volumetric efficiency by over 50%, meaning you get more range without the car ballooning in size, while cutting down on expensive and ethically problematic cobalt. This tech could genuinely shift the conversation from how far can it drive to is this the safest car on the road? And yes, the rumor mill is already swirling about Tesla quietly testing Chinese Blade modules for potential integration in future models, though they haven't confirmed it yet. If true, it would mark a rare moment when a Chinese innovation quietly slips into a Western brand.
If you thought the Blade battery was really good, the Gen 2 version will most likely shock you. This is the new Blade battery coming to market,
Proving its credibility not just in China's mass market, but also in the global premium EV space. Here's why it matters. If Blade-level safety becomes standard, it might finally end those fire memes and push global regulators to raise the bar for what qualifies as road safe in electric cars everywhere. This would ripple out to insurance rates, resale value, and consumer confidence in ways that could supercharge EV adoption globally. The Blade battery is a clear example of how engineering becomes a quiet revolution when it fixes a problem people have learned to accept as normal. It's a reminder that innovation isn't always loud. Sometimes it's a nail test in a lab showing that the future doesn't have to burn. Would you trust your family in a Blade-powered EV? And what's really fueling all this innovation? Overnight genius or decades of hard work? How did a country once mocked for copying leap to leading the world in quantum computing, air taxis, 600 km/h trains, and cobalt-free EV batteries? China's innovation playbook. That's a question that keeps Silicon Valley CEOs up at night, and it's part of the hidden engine behind the Chinese innovations that will redefine the world forever. Economist Keiyu Jin calls it whole nation mobilization.
So this striking swell of innovation happened even though China remains a developing country.
Imagine a system where local governments compete to outbuild each other. Talent scouts pull researchers back from overseas, and manufacturing isn't just a step at the end, but a mindset baked into every part of the design. China's rise wasn't some overnight genius moment. It was decades of gritty, organized obsession with manufacturability, and the mindset that good enough was never enough if someone else could make it cheaper, faster, or more scalable. Carnegie's deep dive explains that this system doesn't just throw money around. It surgically targets sectors like EV batteries, high-speed rail, and quantum computing, pairing state resources with private ambition. The factories you see churning out gadgets were once considered copycat mills, but in reality, they became real-world test labs for engineers to refine every process, every material, and every design flaw until it could survive the chaos of mass production. That's why you now see China rolling out air taxis that are actually certified to carry passengers or quantum computers that can outpace supercomputers, not just exist in a lab. And sure, you'll hear rumors about state-sponsored genius factories cranking out inventions overnight. Reality check. It's less of a sci-fi bunker and more of a constant grind. A system designed to remove friction for innovation while letting bright ideas bubble up. crash into each other and evolve quickly enough to keep pace with the country's ambition. You can almost think of it like the 1980s in Japan, but on a far bigger, faster scale. Factories are classrooms, prototypes are teachers, and failure isn't hidden away. It's analyzed to build something better next week. It's not glamorous, but it's effective. If this pace continues, what could the next decade look like? Are we ready for a world where the limits to speed, safety, and imagination simply vanish? From quantum AI cracking problems in seconds to autonomous air taxis and EV batteries that can bend without burning, China's war on friction and end-to-end speed stack are not science fiction anymore. The only question is, which will arrive at your doorstep first? Quantum power, flight without pilots, or roads without fire risk? And if you could pick just one, which Chinese innovation would you want in your country tomorrow?